Welcome to this sessions on Python sets, which is a part of Module 15, Fundamental Data Structures in Python. In this lecture, we'll explore Python's set data type, an essential tool for managing collections of unique, unordered items. This session includes conceptual explanation and practical demonstration to help to solidify your understanding. Let us begin by understanding what we have aimed to achieve in this session. By the end of this lecture, you will understand what sets are in Python, including their key characteristics like uniqueness and unordered nature. You will be able to learn how to create and initialize sets using curly braces or the set constructor. You will be able to access individual elements in a set and use iteration to process all items. You will be able to perform basic set operations such as union, interaction, and difference, which are especially useful when working with collections of data. You will be able to apply Python's built-in functions like length, max, and sum to manipulate or analyze sets. And finally, you will be able to use common set methods for adding, updating, and removing elements efficiently. Introduction to sets in Python. In Python, sets are unordered collection of unique elements. They are useful when we want to store non-duplicate items and perform mathematical set operations like union, intersection, difference, etc. Sets are defined using curly braces or the set constructor. An example is shown here. Here two sets are defined. My set contains character elements A, B, and C, and the set numbers contains numeric elements 2, 4, 6, and 8. When an element is added to a set, its hash value is computed using a hashing function to determine its storage location within the set. Since the hash value of an element remains consistent regardless of the insertion order, the storage location is determined predictably. However, this does not guarantee that elements will be stored or retrieved in the same order they were inserted. Let us now explore the key characteristics of sets in Python. First, sets are unordered. This means the items in a set do not have a fixed index or guaranteed order. When you print a set, the order of elements may differ each time. So, if order matters, sets might not be the right choice. Second, sets are mutable. You can add new elements to a set or remove existing ones using built-in methods like add, update, or remove. This makes sets flexible and dynamic. We will also discuss various built-in methods later in this session. Third, sets do not allow duplicate values. If you try to add a duplicate item, it will be automatically removed. This makes sets a great way to filter out repeated data from a collection. And finally, elements stored in a set must be immutable. You can store data types like strings, numbers, and tuples, but you cannot store lists or dictionaries because they are mutable and not hashable. These are the four fundamental characteristics of Python sets, making them powerful tools for data management and mathematical operations. Now creating a set in Python. Sets in Python can be created in two simple ways. The first way is by using curly braces. Here we define a set S1 with 4 elements 1, 2, 3 and 4 inside curly braces. When we display S1 with a print statement, the output will be 1, 2, 3 and 4. The second way is by using the set constructor. In this example, S2 is created using set constructor with a list that includes a repeated element 1, 2, 3, 3 and 4. When we print S2, the output will be 1, 2, 3 and 4. This shows that sets automatically remove duplicate values and only keep unique elements. Now let us learn how to create an empty set in Python. To create an empty set, the correct way is we use the set constructor. Here in this example, S4 is created using a set constructor. This creates a valid empty set that we can add elements. But we should be careful if we try to use curly braces like this. S5 equal to curly brace. So we should remember always that set constructor should be used to create an empty set. In this demonstration, we will explain how to create sets in different ways in Python. Let us begin by creating sets using curly braces. Set 1 is a set containing 5 elements 1, 2, 3, 4, 5. When printed, the set may appear in a defined order because sets are unordered collection of unique elements. Next, we create a set of strings. Animal equal to cow, cat and dog. There are 3 strings. Again, we should remember that the order of elements in a set is not preserved. When it is printed, the output is cow, dog and cat instead of cow, cat and dog. Now let's look at a set with mixed data types. Mixed set is a set containing 3 elements with different data types. One is integer, a string and a floating point number. Python sets can hold elements of different immutable types. Now let us see how to create an empty set using the set constructor. Empty set equal to set constructor. Then the empty set is printed with a print statement. We confirm its type using the type function, which returns class set. If we use curly braces to create empty set, it will create an empty dictionary, not a set. So always we should use set constructor to create an empty set. We can also create sets from other iterable types. Now creating set from a list. List set equal to set constructor, and within the set constructor a list with 4 elements are written, 1 2 3 4. Then it is displayed. Then creating set from a tuple. Tuple set equal to set constructor, and within the set constructor a tuple is written with 3 elements, 5 6 7. Then the tuple set is printed. Then creating set from a string. String set equal to set constructor, and within the set constructor a string Assam is written. Then the set is printed. Each character becomes a unique element in the set. Duplicates are automatically removed. Next, creating set from another set, that is from an existing set. New set equal to set constructor, and within the set constructor another existing set is written with 3 elements, 10 20 and 30. This is a valid way to copy or Reinitialize a set. Finally, let us look at initializing a set with duplicate values. Here set is a set with 6 elements with some duplicate items. As we can see, the output contains each element only once. Python automatically removes duplicates when a set is created. Now, initializing sets. Sets can be initialized directly with curly braces or using the set constructor. The constructor can take any items like list, tuples, or even strings. Next is accessing set elements in Python. As we have seen already, to display all the elements of a set in Python, we simply use the name of the set. However, since a set is an unordered collection, it doesn't support indexing like list or tuples. That means we cannot access elements using positions like my set of 0 or my set of 1. Instead, to access or work with elements in a set, we use looping construct, most commonly a for loop. Let us look at an example. Here my set is a set containing 3 string elements: LaTeX, Python and Scilab. Then a for loop is written: for item in my set, print item. Here the for loop goes through each element in the set and prints it. Now let us work with set with some basic set operations. Sets in Python are mutable, which means their contents can be changed after they are created. Let us take an example. This set, set1, contains the name of 3 cities: Guwahati, Shillong and Itanagar. Now, if we want to add another city to this set, say Jorhat, we can use the add method like this: set1 dot add within parentheses the name of the city Jorhat. When we print set1, the updated set will include Jorhat along with the other cities. We should remember that since sets are unordered, the elements may not appear in the same order as they were added. In Python, sets support several mathematical set operations that allow us to combine, compare, and filter data efficiently. Let us go through some of the most commonly used mathematical set operations. First, the union operation combines elements from 2 sets, removing duplicates. We can use the pipe symbol or the union method. Here the syntax of union operation is shown. Next we have the intersection operation. Intersection returns elements that are common to both sets. We use the ampersand symbol or the intersection method for this. The syntax of intersection operation with an example is shown here. Next, the difference operation. The difference operation shows elements that are in one set but not in the other. Set 1 difference set 2 will return elements only found in set 1. Next is the symmetric difference. Symmetric difference gives elements that are in either set but not in both. This can be done using the caret symbol or the symmetric difference method. Python also allows us to check relationships between sets. We use isSubset to check if one set is completely contained within another. We use isSuperset to check if a set contains all elements of another. And finally, the isDisjoin method checks whether two sets have no elements in common. These set operations are especially powerful when working with collections of data like tags, IDs, or categories. Now let us discuss some useful set methods. Python sets come with many built-in methods. Some of them are add, remove, discard, pop, clear, and update. The add method adds an element to the set. The remove method removes element from the set, and it raises error if the element is not present in the set. The discard method removes the element from the set, and it raises no error if the element is not present in the set. The pop method removes and returns a random element. The clear method empties the set, and the update method adds multiple elements to the set. Here in this slide, a program is written with various set methods. The set S contains two elements, and various set methods like add, remove, update, pop, discard, and clear methods are applied to this set S. And here we see the output in this slide. Let us discuss some built-in functions in Python sets. Built-in functions are Python's ready-to-use tools for performing common tasks. When working with sets, these functions help us to inspect and manipulate set data efficiently. Here in this slide, various built-in set functions are shown. The len function returns the total number of elements present in a set. The max function gives us the highest value in the set, while the min returns the smallest value of the set. We should remember that all elements must be of the same type and comparable. The sum function is useful when we want to total of all numeric elements in a set. Sets are unordered by nature. If we want a sorted view, we use the sorted function, which returns a list with elements arranged in ascending order. The any function checks if at least one element in the set is true, while all checks if every element is true. It is useful in logical evaluations. The enumerate function provides both index and value when looping through a set. Though sets are unordered, Python assigns temporary indices during enumeration. Now we will demonstrate how to work with sets in Python. Let's start with accessing elements of a set. We have a set named colors that contains red, green, blue and white as element. We use a for loop to go through each element in the set and print it. It will display all the colors as output. Now let us look at mathematical set operations. First we create two sets A and B. Set A contains 1, 2, 3 and set B contains 3, 4 and 5. We print both the sets. To find the union, we use the pipe operator or the union method. This combines all unique elements from both sets. Here is the output A union B. 1, 2, 3, 4 and 5. Next we perform intersection using the ampersand operator and the intersection method. This gives us the common elements between the two sets. Three is common, so the output of intersection is 3. Then we look at the difference. A difference B gives elements that are in A but not in B. We also use the difference method to do the same. A difference B will give 1, 2 as output. And B difference A will give 4, 5 as set element. Now we find the symmetric difference using the caret operator or the symmetric difference method. This gives us the elements that are in either A or B but not in both. So the output is 1, 2, 4, and 5. Next we will seek for subset and superset relationships. We redefine set A as 1 and 2 and set B as containing elements 1, 2 and 3. We check if A is a subset of B using is subset function. Then we check if B is a superset of A using is superset function. and both will give true as output. Now we check if two sets are disjoint. We take sets x as 1, 2 and y as 3, 4. Since they have no common elements, so each disjoint will return true. Let us move on to set methods. We start with a set S containing 1, 2 and 3. We use the add method to add the elements. We use the add method to add the element 4. Then we use the update method to add multiple elements 5 and 6. The updated set is 1, 2, 3, 4, 5, 6. We remove the element 2 using the remove method. Two is removed and the updated set is 1, 3, 4, 5, 6. We use discard to try removing the element 5. Unlike remove, discard does not give an error if the element is missing. We use the pop method to remove an arbitrary element from the set. Then we clear the set using the clear method, making it empty. We print the final state of the set, which is now an empty set. Finally, let's explore some built-in functions with sets. We create a set named numbers with values 5, 10, 15, 20 and 25. We print the set. We use len function to find the number of elements. It will give 5 as our output. Max function gives the highest value in the set. It will give 25 as output. Min function gives the smallest value, so the output is 5. Sum function gives the total of all values, so the sum is 75. And sorted returns a list of elements in ascending order. So the output is 5, 10, 15, 20 and 25. Let us quickly recap what we have learned in this session on Python sets. Sets are a powerful data structure in Python that store unique elements in an unordered fashion. Each item in a set must be immutable and duplicates are automatically removed. We have seen how sets can be created using curly braces for quick initializations or the set constructor for dynamic creation, especially from other iterable data types like list or strings. Accessing elements is done through iteration using loops, and membership can be checked efficiently using the in keyword without needing indexes since sets are unordered. We also explored set operations which allow you to combine or compare sets in a logical and readable manner. Python's built-in functions such as length, max, min, sum, and sorted further extend the utility of sets by offering convenient ways to analyze and manipulate their contents. Finally, we covered a wide range of set methods like add, update, remove, pop, and clear, which give you full control over modifying the set while keeping its integrity intact. From creation and initialization to set operations and methods, you now have a strong foundation for using sets effectively in real world programs. Thank you for joining the session.